Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video we are going to see one more problem which is based on the second property of definite integral. Let us start with problem number 5. Integral 0 to pi by 2 dx upon 1 plus cube root of cot x dx. Now remember friends, whenever we go for property number 1 or 2 and in the integration we have trigonometric functions like tan x and cot x, always remember that you are going to replace it in terms of sine and cos, and for that you can go for interrelation formulas, as tan x is written as sin x upon cos x and cot x can be written as cos x upon sin x. Here in this case you can see we have cube root of cot x, therefore we will write cot x first as cos x upon sin x, simplify it further and then take it as equation number 1. So we have integral 0 to pi by 2 dx upon 1 plus cube root of cos x upon cube root of sin x. After solving these two fractions, this will give you cube root of sin x plus cube root of cos x, the whole divided by cube root of sin x. Now let us take this cube root of sin x in the numerator. As our integral is now changed in terms of sine and cos, you can take it as equation number 1 and then go for the property number 2, where we are going to replace x as upper limit minus x. Here we have upper limit as pi by 2. So let us write x as pi by 2 minus x. After that, we can use the complementary angle formulas, as sine of pi by 2 minus theta is cos theta and cos of pi by 2 minus theta is sin theta. This will give you integral 0 to pi by 2 cube root of cos x upon cube root of cos x plus cube root of sin x dx. After considering this as equation number 2, you can add these two equations. Therefore, adding equation number 1 and 2, we have on the left hand side I plus I, and on the right hand side we have added the RHS of both the equation. Here you can see the denominator of both the integrals is same. Therefore, we will directly add the numerator as cube root of sin x plus cube root of cos x upon cube root of sin x plus cube root of cos x. Numerator and denominator being same, it will be cancelled. Therefore, 2i will be integral 0 to pi by 2 dx. Therefore, 2i is equal to x within limits 0 to pi by 2. Therefore, 2i is pi by 2 minus 0, which will give you pi by 2. And final answer of I will be pi by 4. I hope friends you have understood this problem. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.